Hello everybody. Today we're going to continue creating animations. Last time we created the time button you saw just execute. Today we're going to create a heart monitor, which is basically just drawing a shape that will animate itself over and over again, simulating the beeping of a heart monitor. We will not be using shape for this. Instead we will use other views that SwiftUI provides that allow us to draw stuff in a specific determined area. I already created a view and added it to a tab view in the Animator showcase. We have worked on this app for 3 other videos. So we'll start with a VStack, and unlike the previous video, we are not going to use shape to animate the heart rate monitor. We could, since it's animatable, and we could just change values over time. But instead of that, we're going to use another thing that also allows us easily to draw stuff in a predetermined CG rect, which is the canvas. So we have the context and the size. These are the 2 parameters that we get to draw. We draw in the context and we use the size to measure coordinates and draw paths. That's exactly what we can do here. We will create a path and we will draw our heart rate monitor there. So let's start first by moving our path. We're going to move the path to the center, so we'll start here in the edge, but in the center vertically, and the heart rate monitor will move horizontally. And let's draw the first line so we can see something. Let's add the path to our context before we continue so we can start seeing how it's being drawn as we add more lines to it. So we'll stroke our context, the path, and here instead of adding the color we add the shading. So if let's add this again, this is expecting for a shading. So we can pass in a color there. And there's our line. So first we go straight, then we go up. We will dip all the way and then go back to the center. With this we have the shape that we wanted, but I want this a little bit nicer, so let's add a stroke style. And we will make the line cap and line join round. And now we want to simulate this being drawn, right? So it's just as if the line was being drawn. How we're going to do that is instead of painting the path is always going to be there, and what we're going to play this is with the shading. We're going to make the shading, instead of a color, a gradient that will have red and black, so it will appear as the line is being drawn, whereas really we're just changing the gradient where it starts drawing red and when it starts drawing black. How do we change values over time? With Canvas, we have another view that can aid us here, which is the timeline view. And this carries 1 parameter, which is timeline, and that's it. And I am missing here, adding what type of thing we're adding. We want animation. Let's start with the gradient first. And let's first add this here, so we can add the parameters. Instead of this, we're adding a linear gradient, which is going to have the gradient we just created up and 2 points. here, what I'm basically doing is just restart the greeting here. And now let's add the endpoint, which this is what we're going to move. That's what we're going to draw. So let's define this as a future variable. We're going to create offset. And we can create a method where we're going to get the offset. Here we'll just get the offset. So where we're gonna get the date, timeline has a date, which is the one that's constantly changing as we are getting updates. The timeline date is the one that's changing, and we will add the size here. Of course, we're getting an error still because we're not returning anything here. We're gonna have an interval. Let's start with, so we can get the preview running. We'll just have the time interval since the reference date, and we return the interval. Instead of that, let's then multiply the interval by the size, by the width. Now nothing is happening because we're not making significant changes. So one thing we could do is use methods. If you saw Apple's WWDC about using timeline, they use a cosine because just that creates a method that will iterate between a specific range, and you can specify it for other stuff. We use cosine here, I think, for snow falling, since it will create positive and negative values. Here, let's see what happens actually. Let's use cosine. And let's multiply by 10. Let's see what happens. There we go. So this is why this is looking like this, because it's earning positive values and then negative, so it's coming back and forth. Sine will do the same thing, so instead let's use tangent. But it's too fast. It's going one way. Let's try just with this. It's a little bit slow. It's taking a lot of time to reset. Let's try with 3. Much better. And notice that we do have to multiply by the width, because if not, I think it's going to be minuscule. Yeah. Okay, 2.5 seems to be doing the work. And we can say that this, actually, thanks to Canvas, we're not tied to the entire width of the screen. Let's change it to 200 and 300. It works perfectly in other more condensed parts because Canvas just draws with a specified size, and all of the path we're using just fractions of that size, so we can adapt to different sizes. And that was all for today. As you can see, Canvas is a very handy tool. You can draw as easily as if you were drawing shapes in the path method. It's very handy. You can see the size that you have available, and with the context you can create a lot of shapes in the same space. So it's also very powerful tool when you want to animate stuff, especially if you want to animate it over time. Timeline paired with Canvas is an amazing tool. Hope you like this video. Bye.